Hello there everybody. Hope you are having a great day. Today, I will be explaining the fetch decode execute cycle. Remember, everything shown is only an abstraction and is not representative of what the components look like. This is the abstraction of the CPU along with the main memory.
Control unit. In charge of organizing the sequence in which program instructions are executed, followed by decoding the instructions. Decoding an instruction means that the opcode and operand of an instruction are analyzed to determine what needs to be done to execute the instruction. This means that the control unit is responsible for using control signals to enable data to be read from and written to the main memory. Decoding every instruction that the processor will execute to determine what needs to be done. Organizing the sequence of micro-operations that need to be performed to carry out an instruction. And using control signals to determine the operation the ALU will carry out at each instance. ALU. Arithmetic Logic Unit. The ALU handles performing arithmetic calculations and logical operations that include addition, subtraction, multiplication, division. Logical bitwise operations, such as AND, OR, NOT, and XOR. Comparisons between values, such as greater than, less than, equal to. And shifting binary patterns to the left or right.
ACC. Accumulator. Stores the result of any calculation processed by the ALU. The processor accesses other general-purpose registers where temporary values are stored while calculations are completed. Any result exists in the accumulator.
Opcodes and operands. An opcode, operation code, is the part of the instruction that specifies which operation the processor should perform. For example, an opcode might specify the loading or storing of data. The operand contains a value, or set of values, relevant to the opcode. The operand can be an actual piece of data, or it can be a reference to the memory location of the data for the opcode to act on. For example, when the opcode is a store instruction, the operand contains the memory location where the data should be stored. Memory. RAM, random access memory, is used in the fetch decode execute cycle. Within the RAM, the memory is split up into separate locations, each of which is given a unique memory address. The processor will use these addresses to access the data stored in RAM. RAM is volatile, meaning power is required to hold the data, and if the power is switched off, all the data stored in RAM is lost. RAM is often the highest capacity form of main memory. The bus. The bus is an electronic pathway through which data can be transferred, such as data, addresses and instructions. On the scale model, the bus is hidden.
PC. Program counter. Holds the address of the next instruction to be executed by the processor. MAR. Memory address register. Temporarily holds the address of the memory location that the processor needs to access, either to read from or write to. MDR. Memory data register. Temporarily holds the data that are read from or written to the main memory. CIR. Current instruction register. Holds the current instruction that the processor is executing. SR. Status register. Used to store information about the result of the last instruction that the ALU executed. Each bit within the status register acts as a flag to indicate if an error or exception has occurred within the process, or to enable or disable interrupts to be raised. An error or exception is when the result of a calculation requires further action. An interrupt is an event outside of the program process that requires the attention of the processor. Now for the actual fetch decode execute cycle. Fetch. PC is at 0. This copies over to the MAR. The address is placed on the bus. Once the address of the instruction is on the bus, the contents of the memory location transfer to the processor through a memory read operation. The control unit sends this. The instruction that is stored at that address is transferred using the bus from the main memory to the processor and is saved in the MDR. Simultaneously, the contents of the PC are incremented by 1 so that they point to the address of the next instruction that needs to be fetched. If the instruction was to go to a specific memory address, then the PC will instead store that address. The contents of the MDR are copied to the CIR. This ensures that the current instruction is kept safe so that the MDR can be used later to store other data. Decode. The control unit decodes the instruction that is kept in the CIR. This involves splitting the instruction into operands and opcodes to determine what type of instruction needs to be carried out, checking if additional data are required from memory, and figuring out where these are kept in main memory. Execute. The exact sequence of operations depends on the type of instruction that is being executed. For an arithmetic instruction, the type we will focus on right now, any required data is fetched from the main memory, then the calculation is executed by the ALU, and the result of the instruction is stored in the ACC, a general-purpose register, or back into main memory. The data from the ACC can be retrieved again to perform another operation upon it. For a comparison between two numbers, the result will go to the SR, which will raise a flag to say either equal or greater than. If neither of these flags are raised, it means that the entered number is less than the previous number. Bingle bangle bong. Bingle bangle bong.
Bingle bangle bong. Bingle bangle bong.
Bingle bangle bong. You now know what happens inside the CPU of a computer. The calculations within the CPU could lead to this.
ジョワリだ。